Hello everyone. Welcome to another webinar series done by 99X. So today we'll be talking about monitoring performance in Azure SQL databases. I'm Tarid Fernando. So I work as a senior tech lead in 99X. So I've been mainly working on developing software for cloud. And so we have a lot of experiences on databases regarding HSQL. So we have started HSQL databases when it was introduced to the market, and now I think they are in a very good state in terms of feature set. So a lot of people are trying to migrate to HSQL from on-prem. Yeah, so today we are going to talk about some interesting things. So this is for the agenda for today. And initially we'll be talk about what is HSQL, some brief description about it. And then we'll be going through some monitoring basics that you can do using the Azure portal. And also how can we do some high level tuning using the Azure portal based on the statistics that we have. And then we'll be going into detail how to use query store and what are the basic metrics or basic things that we can do to find out like which query causes the CPU load or IO load in the SQL server, so we can troubleshoot those. And then describe we'll try to explain about the read-only replicas, which will be useful for some tuning scenarios in your applications. And then we'll be talking about SQL Elastic Pools and how can we use it for multi-tenant databases in your applications. And lastly, about DTU or VCO purchasing models that's available in the HSQL. Yeah, so what is SQL? So this is a code from Microsoft. So it's a highly scalable, multi-tenant and a highly available PaaS platform as a service from Microsoft. And the nice thing about it is it's almost 100% compatibility with the SQL Server Enterprise Edition. So for as developers, there's no like difference at all when you're writing code, writing SQL to SQL Server or SQL. But for DBS, there can be some limitations. Yeah, because you don't have the bare metal access when it comes to SQL. And the nice thing, of course, with the Plus is they provide you with the automatic patching and like the version updates seamlessly within a maintenance window that you can configure. And then finally automatic backups, so which is a lifesaver, and you can do like point in time restores, and there's a lot of configurable parameters available in the SQL. So you can do a lot of things there. There's a lot of rich feature set from Microsoft on that. And yeah, talking about tuning, of course, we have to explain it through using a database. So for the example, we'll be using the Stack Overflow database, which is like an open source database that they publish. And this particular DB is from 2008 to 2013. And it weighs around like 50 GB without any non-clustered index. So only clustered index are there. And yeah, until 2013. And so I did a select count, and it was around 17 million posts from 2.5 million users. So you can actually download this using the link, and you can Google search. And there are like more like large databases like this is like a medium scale database that you can work on. So when you want to figure out like how to do performance tuning, this is a good data set to begin with. So initially we'll be trying to go through the monitoring basics using Azure portal. So we will try to see what is the DTU percentage, CPU, data IO, log IO that you can see, and setting up alerts, and finally diagnosing. So we'll be trying to demo these through the Azure portal. So I have restored the Stack Overflow database in a resource group that I've set up. So this is the database server. And the current pricing tier I have put is like general purpose serverless, because I don't have like much credit left in the subscription, and like it pauses when you are not using it, so I can save some money. And so here you can't see the DTU, of course, because it's a VCO based database. But if you have select DTU, you can see the DTU utilization here instead of these. And So I'll just increase the time window a bit because yeah, I have done some experiments. So I try to stress the database so everyone can see some metrics that you can observe. Yeah, so here you can like when you go to the database itself, you can quickly see something is happening. So something is reaching 100%. of this. In this case, it's a red line, which is data IO. So something bad is happening, and I think most probably it's doing some index table scans because I don't have any non-clustered index. The CPU percentage seems fine, and I don't have a log IO that much because I'm just doing reading mainly. I haven't inserted anything. So if you click on this, you can go to the matrix and like then you can add more parameters here. So you can just click add metric, and there are a bunch of things that you can do. So I'll try to successful connections. Yeah. So yeah. So these are the successful connections. So you can do a lot of things into it, and you can like change charts, and it's similar to what you have in the other Azure services as well. Uh, yeah. So the nice thing about is like this is like the main point that you can diagnose your database for any possible issues that you have right now. And for the matrix, you can actually set up alerts. So if you go to diagnostic, uh, monitor monitoring, you can set up alerts. Then you can create new alerts based on the database matrix. So you can click new alert rule, click select the database, and then you can click conditions. So here, yeah, signal type, you can select matrix, I think. Stick on it. Let's give it a couple of seconds. Maybe I'll try to add it again. Okay. Yeah. So I'm not sure what yeah, why it's not loading, but like here you can select like matrix, and then you can select CPU percentage, IO percentage, or log IO percentage. So there are a lot of parameters there, and for you can be, so example you can set up a lot like this. If the CPU percentage goes over 90% within a 5 minute time window, and you can set the frequency as well, then you can set up a alert. So the action groups can be, you can send an email, you can you can execute automation script using automation account. So you can scale up the database if you want, or scale down. So there are a lot of configurability that you can do using this functionality. Yeah, okay, fine, it comes. Yeah, so the CPU percentage, so this is my CPU percentage over the last 6 hours. Maybe I'll increase a bit. So I have more peaks here, and then you can put the threshold, so 80, and frequency of evaluation. So every 1 minute, it will go into check the CPU percentage, and over a time window of 5 minutes. Also, they have introduced this dynamic feature, so which is kind of like they try to calculate what is your regular CPU usage, and based on that, it will try to set up alerts. So I normally go with the static, but you can try out dynamic alerts as well. So yeah, that's a very nice feature to have from when you are like when you want to monitor your production databases. Yeah, let's go to the slides again. And the other thing is like Azure SQL Analytics. So if you have worked in Azure, like you must be comfortable and you should be using the log analytics workspace. It's a lifesaver when it's come to logs because it has a lot of functionally integrated into one single place. So in the Azure SQL DBs as well, you can use this. So you can go to diagnostic settings. Seems like there's a slowness here. So I have already set up this diagnostic to send these logs into this log and workspace that I have created. So here you can see SQL Insight, automatic tuning, errors, timeouts that happens in database, blocks, deadlocks. Most of things you can send it to the log space, and here you can query upon that. So I will try to go to there, and this is the Azure SQL Entry solution that I have configured. Summary. So this feature actually in preview, so it's been I think been a while. I'm not sure why they haven't released it to GA. So here it gives you like a very high overview of like the issues of some matrix you have. So there are some interesting sign number of errors. So I was trying to stress the database. Yeah, so there are a bunch of errors created, and then number of timeouts. So you can go to the uh, go to the actual very detailed manner. So you can select who initiated this query. So hopefully it will load. Yeah. This. Yeah. Yeah. You can get a lot of information using this, and also the waiting types, which I will explain later. And you can get this top performance issue. So I will explain this later on as well. So this is like the SQL Analytics workspace that they have introduced, and like I highly suggest you to enable it in a production DBs because it provides you with a graphical view of like what's going on, what's happening in your database, and it presents you in a very easy to read way. Let's go to the slide set. And yeah, the next feature the Azure provides us in the Azure SQL is the performance tools. Yeah. So by the way, if you have any questions, you can put them into the comments. So at the end of the session, there's a Q&A session. So I'll try to go through all the questions that you have. Yeah, so let's check out the performance tool. So in the database, you can find the intelligent performance, and here you have this performance overview. And this database was created like 3 or 4 days back, so I don't have much statistics to. So Azure SQL can't generate any recommendations for me, but I will show you a recommendation which I have got in another database. And here you can see like what are my top 5 queries by CPU consumption, and then you can go into more recommendations as well. So you can see resource consuming queries, and you can use CPU data log. So under the hood, this intelligent performance tool, it uses query store, which I'll explain in detail a bit later. But here, like using the Azure portal itself, you can easily see. So this particular query, so I will just top 5 queries by CPU, and this query is taking a lot of CPU, so I can just click on it and get the query ID number and also the query text. So this particular query is like a stored procedure. It's try to count the accepted answers based on some conditions. And this one has executed like it shows the execution count. So here it gives the time slots and the counts that query has been executed. So this in this time slot this query has executed 2 times, and for total duration of 1 hour 43 minutes, which is very bad. And it has done a data percentage of 95%. So things like that you can easily see using here. You can select recommendation as well if you have anything. And here also in the other tab, you can see the long running queries. So these are the top 5 queries by duration. Yeah, so here also you can quickly see what are the queries that is misbehaving, or you have to check like what is the execution plan, or you have to do something upon it. And then you can go to custom and customize the metric types. number of queries. So you can do like this as well. So if you want to do more detail, I recommend you to go to the query store and do that, because it's a bit nicer and it's more responsive than this web page. Yeah, but you can do a lot of things here as well. So let's get to the slides again. And so the other section that I want to cover is like automated tuning. And here there are the three features that Azure SQL provides you with. One is index recommendations for creation, dropping, and also forcing the large good plan. So we go to the portal and see. So here it's under the intelligent performance section as well also. So by default, the force plan is enabled on. So when you create a new server, it's on by default. But I believe like it's a good recommendation as well to keep it on. So what does is, if you have like a single query which executes in a like a very fast manner, and suddenly it performs very badly, HSQL will figure it out and try to use the plan which executed better, so that bad plan goes away. Uh, and these are the two the other features that you provide: creating indexes and dropping indexes. So when you have more statistics, of course I don't have here because it's a really new database, it will suggest you, okay, you can create this non-clustered index. So I can show an example actually. So see, this is one of the examples that I have got. So here they are recommending me to creating a non-clustered index, and this is like the database table and index C columns and the included columns. And here you can see the impact also. Impact is low. So if I create this index, uh, it won't have much impact, but the disk space is like huge, like almost 8 GB. So most probably I won't create this index. So here it gives like sometimes it gives good recommendation, so we can use this. Yeah, talking about indexes, so like the main thing is like as developers, like when something goes wrong or DBS, we just create a non-clustered index and like, okay, it magically works better, everything is fast. Then we forget about it, right? So months go by, then suddenly that query performs bad again, because you forget about like maintaining that indexes. So it's very important. So if you create non-clustered indexes, so you have to always maintain the indexes. So you have SQL Server will have better statistics to get the data fast and efficiently. As a practice, like in our customer, like we try to maintain the indexes every night when the customers are not working, like no off-peak hours. So it depends on your usage. So if the customers are not using that much, can get away maintaining your indexes in the weekends also. So based on your usage and demand. So that is very important as well. Yeah, the next I'll talk about the query store. Uh, so the query store feature was introduced by Microsoft in, I think, SQL Server 2016. For Azure SQL DBs, it's enabled by default, and it has a very minimal impact on the database performance, and like it's like the best friend for DBS and developers who want to investigate the issue. It's like a flight recorder because it records everything. It tries to record the queries, the runtimes, the plans. So you can get a good overlook using this. And it has some features as well. So similar to Asia Portal, we can try to force the execution plans uh, also. And there are some features like you can easily find regress queries. So what is regress query? It's like a query that works normally like a couple of months back, and it performs worse a little by little, and then it doesn't work. So that is like the example for regress queries. So you can easily find those using query store. And there are some other features as well. So you can identify the top resource consuming queries or expensive queries, if we think about data or CPU. So let's move into SQL Management Studio. So I have connected to this database, what I have shown you in the Azure portal. And if you expand the database and go to the query store, so if you can expand, there are a couple of sections that you have. So the first thing is the request query. So let's try to expand this. And so in the query store, there are it's like a similar UI for all these options. So first thing, you can just click on the configure, and you have to see the time interval. So I pick the last hour. I haven't done anything, so I pick last day and try to OK it. Okay. Yeah. So okay, I'm getting some statistics. So I have two queries that is as request. But for production database, which has a lot of queries, I think it will give you a more useful input. And if you click on this things, it will show you the query that has been executed. So this is a query from the what query store has executed. So of course, the variables are not there. It is truncated. And then it will give you if there's any missing indexes, it will give that suggestion also. And also, most importantly, the plan, execution plan. So you can analyze here. So here it's doing a index and on the post table, which should be very, very bad, because it's reading the, I think, the entire database table. So this is the most probably the reason this query is slow. So things like that you can easily figure out using this. So another important thing is top resource consuming queries. Okay, so I'll try to increase the time interval a bit. Okay, we have some good data here. And so here in the left side, there's a couple of metrics. So duration, CPU, logical reads. So when it's, so if you select duration, this is like a outlier. It takes a lot of time. So you can see the query that is responsible for this. I think we saw this in the Azure portal as well. And this is the execution plan. So as you can see, the query plan gives you more detail. So you can get the query, you can get the execution plan, then you can test it out in your test or staging environment and see what you can do about this. And the other thing that the query store can do is like it provides you with the plan. So for this query, so it has recorded only one plan, unfortunately. So if there are any multiple plans, you can click on the plan and it will give you the execution plan for each plan. And then you can click and you can also force plan it. So this is feature I was talking about earlier. So you can do this manually as well. And here I have this plan ID 36 and with 2 execution times. So most probably this is 2 users. So based on the user ID, if you, for example, if you haven't answered that much, so there is less data, so you can get less runtime. So there are a lot of things that you can do here as well. And there are some more things that I won't explain everything, but this is a little bit interesting as well. Query weight statistics. So when you are like doing a multi-tenant like a SaaS application, a lot of users access your database using multiple threads, right? So then you have all sort of problems. Queries are waiting for each other to release logs, so releasing the commit transaction commits. So you can easily diagnose those sort of issues using the query weight statistics. Yeah. And yeah, this is a good point as well. Yeah. So let's go to the slides again. Yeah, and so I'm going to talk briefly about the read-only replicas. So this is like available in Azure SQL when you have configured the DBs, the server. with always on availability group. So you can actually configure this up to 8 replicas, and this is so the cool thing about read-only replicas is you can actually read data from these replicas, right? As the name suggests. Suppose that you have a reporting workload, or you have the Power BI instance who want to query upon, but you can't sacrifice production database performance. So you can easily use a read-on replica. So you have to actually match your use case and like think that if it's suitable for you before using it. It's because it's not like a silver bullet for like reporting workloads as well. Uh, and the thing is, like, it's not a real time, like it syncs the database with a latency. Uh, so your workload should be okay with that. So you can miss some data, so which is in the primary database. And the other gotcha is, I think most people like they don't realize is like so suppose that like you are doing a reporting workload and you have this huge database query, and you try to run it in the secondary like a read-only replica, and it doesn't have index. So the thing is, read-only replica is a read-only replica, so you can't create any indexes on that. So even though you are running that query on a read-only replica, you have to create the indexes on the primary database. So it will have some effect on the primary DBs as well. So you have to think carefully when you are using read-only replicas, because it has so many conditions, and like you should evaluate before using it carefully. And the other the feature that SQL like they promotes a lot is the elastic pools. So this is like a very useful tool feature for like when you have multiple DBs. Suppose that you are like developing a multi-tenant solution, and you are spinning up a database per customer. So some applications do this, and then you have this huge number of databases that you have to manage. And so if you go with the normal traditional approach on like making the resources, you have to think about uh, if you have customer A, customer B, customer C, what is customer A's demands, like is he using heavily at this time, because you need to optimize the cost as well. So elastic pool is kind of a feature, like a good feature for them, because it provides you to if it provides you some set parameters that you can set up for database. So you can, for example, you can set this is my minimum DTU and this is my maximum DTU. Then SQL Elastic Pool will distribute those resources automatically based on the demand. So it can actually auto scale. Individual DBs can auto scale within the setup parameters. Suppose that that's a very like a small customer. He doesn't have like much load at all, but suddenly he tries to do a very large write workload in the database. So Elastic Pool can quickly cater that and like try to increase the scalability. Like it will try to scale up that database instance using the Elastic Pool. So this is a very nice feature which you can use, and also of course depends on your usage demand. And lastly, yeah, I want to talk about like tuning database from a dev perspective. So we've been doing this for a couple of days, a couple of years actually, and we have some lesson learned. Uh, so first thing is like as a developer, like when you are writing the SQL query, so the ORM, when you're accessing data, you have to think, you have to try to create your indexes like non-custodial index based on your application usage pattern. So you have to gather a lot of statistics. So suppose that you have this database table orders. Is it a read heavy database table, or is it a write heavy database table? Is it both? So you have to think how this table use, what is the usage patterns, how the customers can access this data using the user interface. So based on that only, you have to drive your index strategy. That is very important, because if otherwise, if you create an index, it will affect other part of the application, and which you have to troubleshoot again. because yeah, you have to fine tune. Like there's no perfect answer, so you have to it based on your application, it based on your customers. And another thing is we like to like create as much as indexes to cater the queries so we can quickly get results. But the problem is sometimes these indexes get unused. It's very important that using dynamic management views, DMVs, you have to check whether there are indexes which are not utilized, because that's a waste of storage as well as maintenance. And like try to don't rely on automatic function in SQL. Have some more focus on the database instances that you are running. How is my indexes doing? And another scenario is like when you are like writing a lot of data into database, like 5,000 or 10,000 or even more than that, you can use bulk inserts, which speeds up a lot. And also weight statistics, as I explained earlier. Weight statistics will give you more insight on like how when customers like access your database in a multiple places, in multiple threads, how it affects your database. So yeah, this slide is about how to like choose your correct DB pricing tier. So in Asia, you have two. One is the DTU model, and which is like they started from this, and they later on introduced the VCO model. So earlier with DTU, it's like they package the database, the pricing tier with the compute and storage at one. So when you increase the DTU, it will increase the storage as well as compute. And likewise, suppose that you have an application that is very CPU heavy and like very less storage. You need only 30 GB, but you need to have like 300 DTU. So it's a waste of money to go for large DTU because you are not actually using the storage, right? So in that case, it's better to go for VCO model that they introduce. So it's basically you can tweak the storage versus compute. So we can say like what is my required VCO level, like how many VCOs I need, or how much GBs I need for my storage. Yeah, and so basically, so if you're coming from on-prem, I think Azure Microsoft provides you with a like assessment tool that gives you a number of DTUs or VCOs that you may need based on your workloads. So that's something that is interesting for you. And typically, as a general rule, 100 DTUs in a standard tier is equivalent for one VCO, and 125 is equal for one VCO, that is, which is in premium tier, which uses SSDs. And Microsoft recommendation is like if you above 300 DTUs, try to go for VCO. So there can be, of course, exceptions. Yeah, but yeah, you have to check and see how it performs, because you can easily. Nice thing is you can easily switch between these pricing models, so without much effort. Yep. So I think yeah, I think we are at the end of the session. So if you have any questions, so I'll try to answer them now. So please put any comments or questions that you have. So I think we haven't got any questions so far, but we'll try to keep the session alive for a couple of minutes in case if you have any questions. Okay, I guess yeah, we can wrap up the session. Yeah. So maybe I think if you have questions, please put comments so we can maybe later reply. Yeah. So thank you for listening in. So hope you gain some more insights on like tuning HSQL databases. So like feel free to like subscribe and the YouTube channel. Yeah. Thank you. Bye bye.